Hello and welcome to Building a Batch Platform on Kubernetes. My name is Mofi. I'm a developer advocate at Google focusing on Kubernetes.
And my name is Ali, and I'm a solutions architect at Google. I partner with Mofi on high performance computing and AI infrastructure.
In the last video, we saw a traditional architecture of an HPC platform built on Kubernetes. In this video, we're going to look at the fundamental block in Kubernetes that allows us to run batch workload on it.
And that fundamental block is the job API. A job creates one or more pods, which are basically one or more containers, and will continue to retry execution of those pods until a specified number of them successfully terminate. So let's go ahead and look at an example of a simple job. You'll notice that we're inside our Cloud Shell and we're defining the YAML template for this one simple job. You'll notice that the API version is batch version 1. The kind of this entity is a job. Metadata contains simple identifiers like name or a namespace where this job can exist. And then inside the spec template spec, you can define your containers that run as a part of this job. Since we don't define any counts, it's assumed that this is going to be a one pod job in which it's going to run the Perl 5340 image with the command shown in line number 11. You'll notice that line 12 also talks about the fact that this job must never be restarted. So let's go ahead and apply this manifest. We're going to say kubectl apply-f simple job.yaml. As we can see, the job has been created. So let's go ahead and check the status of this job. We'll notice that there is one job that is still running at this time. And here we can see the pods that contribute themselves to this job. Now that we know the name of our pod, let's take a look at the logs from it. As you can see, this is pi to the 2000th decimal place. And if we take a look at the jobs, you'll notice that this job is now complete.
The example we just looked at is an example of a non-parallel job, where we only started one pod and the job was considered complete when that job was completed. If the job somehow failed, Kubernetes will try to restart the job unless we set restart policy to never, in this case, which we did. In many cases, we actually want to run the job multiple times to complete a larger task. In those cases, you want to set completions to greater than 0. Let's quickly take a look at an example. Here we have a job that is very similar to the job that we just looked at. The only difference being on line 6, completions is set to 4. Let's apply this job with kubectl apply-f completions job YAML. We'll see a job completions was created. If you do kubectl get pods, we'll see I have one of these jobs running. If I check again, we should see the one has completed and the second one is running. Because our job has a completions number set to 4, we'll have to run 4 pods to complete this job. Because the value of parallelism is not set, our job can only execute one pod at a time. In the end, we should see all 4 of our pods has completed. And by looking at their timestamp, we can tell they run one after another. We can also see kubectl get jobs that our job has a completion of 4 out of 4.
So now that we've seen how a job with completions works, let's take a look at a job where we can define the number of parallel pods that get processed at the same time. You'll notice that in line number 7, we define parallelism as 2, and the rest of the YAML remains the same as the example before, with the completion set to 4. So let's go ahead and say kubectl apply this manifest to run this job. Taking a look at the pods, you'll notice that 2 are running at the same time. You'll notice the 2 of them are now completed, and the other 2 have started just now. And just like that, all 4 of them have been completed with 2 at a time. Sorry. As you can see, all 4 of those workers have been completed, processing 2 in parallel at the same time.
In batch processing, often we have workloads that needs to communicate with each other to coordinate a certain task. For those kind of workloads, we can take advantage of indexed completion mode, in which each of the pod in the job will start with a static index that we can refer to communicate and identify the specific pod. We can set spec completions and parallelism to a specific number, an exact number, and have a service for inter-pod network communication. Let's look at an example. Here, we have a service definition of a headless service where cluster IP is set to none. This is an intra-cluster service where we do not need a cluster IP for this service because we're only using this to get a domain name for our pods to communicate with each other. In our job definition, we have of kind job, name index job. In our spec, we set completions and parallelism to the same value of 3 and completion mode to index. In index job, each of the pod within the job gets a static index starting from 0 up to n minus 1. In this case, our indexes will be 0, 1, and 2 because we have 3 copies of this pod. In our template, we set a subdomain of headless service, the name of our service. We set restart policy to never. And in our container, we run a bash script that for each of those pod tries to ping the other pods within the same job. When all of those succeeds, we consider this job done and the job successful. This is a simplified version of jobs where pods need to communicate with each other to complete a job, for example, like MPI jobs. Let's apply this job with kube control, apply dash F, index job. We'll see that headless service and index jobs was created. Kube control get pods. We'll see 3 of our pod actually started and completed almost immediately. We could take a look at the log of this pod by running kube control logs of this pod. We'll see that our pod managed to ping itself and 2 of the other pods that's running. We could check that for some of the other pods as well. We'll see the same log because each of them are trying to ping each other, including themselves. To recap, in Kubernetes, jobs are the fundamental building block of running batch workload. The most basic configuration of job only consists of about 10 lines of YAML where we define our job name and the container that should execute for the job to complete.
We then look at a very similar job where we define completions. For example, a workload that might require multiple workers to complete their work for the job to be considered successful.
If we want to take advantage of using our resources to do the job quicker, we can set parallelism to a number higher than 1 to speed up our job execution time by running multiple copies of the pod to complete the job quicker.
In the last example, we saw an indexed job paired with a headless cluster IP service. This service is local to the cluster and provides a domain name for the workers that will participate in this indexed job. Each worker pod will have an index associated with this job as a part of their host name. And this is useful for those workers to be able to reliably find each other and communicate with each other as a part of this job's workflow. So in this video, we saw several different ways of configuring jobs as batch workloads on Kubernetes.
If you want to learn more details on how to configure jobs and control job behaviors on Kubernetes, we have a video on the channel already that you can check out.
Hope to see you all there.